In this video, I'm going to show you what a regressor is, show you how to create one and how to use it. But first, what is regression? Regression is when you can map from one space to another space, where each space can be any number of dimensions. So the core of a regressor is a neural network. This is what lets us map from one space to another space. So in this example here, I'm going from a 2D input to a 4D output. So when I move this around on this XY grid, you can see that the values on the 4D output change. So we can take that same idea and now build up an actual regressor. So what I have here is the same 2D grid, so I can move this around. And then here I have a synth engine. So if I open this gate up, we'll hear that. All right, now I'm going to randomize it just to get kind of a different sound here. Okay, that's kind of an interesting sound there. So I'll turn this audio off for now for a second while I explain some of the ideas. In order to build up this regressor, what I need to do is add points. So I need to give it a set of input vectors. So this will be this XY grid here, and then a set of parameters that will correspond, which is what the regressor is going to interpolate between effectively. So in this case, I have this one sound. Okay, and I want that to correspond with, for example, this position on the grid here. So what I'll do is I'll dump these settings. So this is the parameters for this specific sound. Okay, I'm going to add this point. And now I'll print the results just to kind of see in the background that I've added that. So I can see that the synth settings are there, and I can see the corresponding thing. So what I'll do is I'll just create a few more of these points. It's kind of interesting. So I'll have that mapped here. So I'll dump, then I'll add point. And again, I'll print just to make sure. You don't need to print every time, but it's handy when you're building it up. Okay. Okay, I'll map that to here. So dump, add point, and then let's make one more. Sure, why not? Okay, and I'll have that mapped to here. So dump, add point. So now I should have 4. So these are my different synth presets, and these are the different positions. So once I've set this up, I can begin training the network itself. So I'll just take this on. You can see it happened like basically instantly. Once that's done, I've trained up a regressor where in this case, each individual corner corresponds with the synth preset. So that's the core thing that we're doing. Now, when you're building up a regressor, it's not as, you can just do that and just have individual, in this case, singular positions that map to stuff without necessarily considering the sonic result of the synth. But I found what gives me better results, so I'll clear this here, is to have some kind of thought of the sonic space that you want to basically play. So in this case with the regressor, I've only given it 4 points with corresponds to the corners, but most of the playing that I'm doing is moving around all this area in between. So 99.9999% of the playable space of this regressor is spaces that I didn't define. So the areas between these presets. So that's an important consideration when you're building this out. So let me do that again. I'll take that as kind of like a starting off point, and that's kind of like a low sound. So maybe I want that to be down here. So I'll dump, add point. Now let's say I want a kind of a variation of that. So instead of just randomizing it completely, I can randomize it by 5%. And that's kind of interesting. Maybe I'll map that here. So I'll dump and add point. And now, that's kind of interesting. Maybe I'll put that there, dump, add point. And now let me randomize something completely different. Okay, that's kind of chaotic. Maybe I'll put that here. So not all the way at the end, but sort of here. And I'll dump and add point. And that's kind of cool. So I'll put that maybe closer to the edge, but not all the way at the edge. I'll dump and add point. So that's kind of a variation of that. Maybe I'll put that here. And let's add a few more. Kind of like that. So sort of a bit of a pattern. So I'll put that maybe here. So So dump and add point. I've got a bit of a siren thing, and I'll put this down here. So it's dump and add point. So I've added 8 points now. So I'll train it up here. Okay, so this one we actually saw the spike, but then it dropped off very quickly. So now let's hear this mapping. Okay, so I have a bit more control in terms of the types of sounds that I have in different places. And then by putting things near the edge but not at the edge also affords me the ability to go beyond the space that I mapped. So in the regressor, I only gave it this as the furthest point, but I can actually go out to here. So let's hear what that sounds like. So that's an interesting thing, but particularly, I mean, some of this is specific to a 2D grid, but by putting things not near the edge of what you're going to be doing, you can do some more complex mapping. But all of that is to say is that when you're training up your regressor, you want to build up a space that you find both sonically interesting and then spatially, or whatever your input vectors are, have that be considered as well. And that'll give you a bit more of a sophisticated regressor. Also, it's worth mentioning that when you train it up, you want to train it till it kind of drops very quickly, but you don't want to carry on training forever. So if I keep training here and let it go down to like 0, what I'm actually doing is overfitting, or I run the risk of overfitting. And what that means is it'll regress to the point where like this exact point will be the preset that I put there at the expense of all the things kind of in between. So what if you let it go for too long, you end up basically overfitting is the term for it. And it could just make the mapping, the space in between, not as good. So what you want to do is once you get a big drop off, maybe let it run a bit more and then call it a day and you're good to go. So this process I explained here works well with all of the built-in synth engines. So the Wrangler, Quantasi, 4Cs, Mangrove, Just Friends, all of these have these randomized functions and the dump function. That's the main thing that you need to use the regressor in this way. So here I have an example of take the output from the dump output into the regressor create. Optionally, I can send the audio as well. And then I have whatever is going to go into the regressor. So this could either be descriptors or a controller space or whatever it is. But these are the connections you need. Now, if you want to use something other than one of the built-in synth engines, there's a couple abstractions that will let you use either Max for Live devices or VSTs. There's this M4L helper, so Max for Live helper, that will let you do a lot of the same functionality. So I can randomize things, I can dump, and I can use that to train a regressor. Similar here, I have just one of the generic built-in VSTs. I can randomize all the features there and dump the messages out. So this will let you connect to regressor create in the same way that I'm doing with the built-in synth engines. However, if you have your own algorithm, you can use something like this. So this is, I'll probably develop this a little bit more in the future, but the idea here that I can specify a parameter name, its minimum and maximum. So in this case, I have a list formatted as like parameter name, low range and high range. So I put that in and that shows me that. Then once I have that, I can then generate a bunch of values. In this case, it'll make apples sort of a random parameter within that. And then this is what you send to regressor create. That's one way to go about using the same dump functionality that I have with the built-in synths or with this Max for Live or VST helper. Now, once you've created a regressor, you have an option for the different types of outputs. So by default, it does the iterated output, meaning that it will do all the parameters. So if I print here, you can see it's dumping each time I click, it's dumping a whole set of parameters. So that's the default that lets you plug the regressor directly into a synth engine or whatever. Now, you also have an option for a laced list or raw list. So what a laced list does, it gives you all of the parameters at once. So frequency and then its value, chaos and its value as a single laced list. Now that's useful in the case where you want to, perhaps in this case here, I'm taking the regressor and then I want to set all the values and then I want to ping a low pass gate. In this case, what I want is I want to have all the values set and then ping. the filter. Otherwise, I would just be setting one value and then pinging the filter, setting the next value and pinging the filter, setting the next value and pinging the filter, which isn't ideal. So that's why you would use a laced list. And the final option here is the raw list. And what this does, it just gives you the numbers on their own. So without the parameter names. That's useful if you don't really care what the parameter names are, or if you're using a synth algorithm where the specific parameter names aren't required. So in this case, I'm manually unpacking that. Okay, so those are the different output options. Now, just to show a little bit of a, not necessarily an advanced thing, but a different thing that you can do with the regressor. Some of what I'm showing here is built in under the hood, and some of it will be incorporated more in the future. But since with a neural network, all I'm doing is taking some input dimensions and turning that into whatever output dimensions I want. That could be, in this case, most of the examples I've shown is controller input going to a synth output, but the input and output vectors can be anything. So what I can do is I can morph from descriptors, which are just lists of values, to other descriptors. So in this example here, I'll just kind of play a moment there. What I can do is I can analyze 32 samples, which is like preposterously small, and I can regress that to a predicted 256 window analysis. So this analysis window here, like this one here for spectral shape and this one here for descriptors, is the default settings in Datanode. So if you analyze spectral shape and if you analyze descriptors, these are the values that you typically get. Okay, and that takes 256 samples of latency to compute, which is about 5 milliseconds, which is crazy fast, but it's still some amount of time. This here on the right is the predicted version of that based on 32 samples of analysis. So I'm doing the onset detection. I'm analyzing the 32 samples, the first 32 samples. I've trained the regressor on this, and then I'm predicting what that will sound like. And you can see that they're very, very, very similar to each other. So I mean, it's not perfect, but with effectively like sub-millisecond latency, you can have a really good idea of what the descriptors will be. So as I said, some of this is happening under the hood. So when you create a setup using setup create, it is doing this, but from 256 to 4,410. But this is something that you can do with a regressor as well. So predicting descriptors. And then finally, to show a couple of use cases here. So here I've got a couple of the built-in synth algorithms. So I've got Quantussi, a Forces, a Rungler, and here's another Quantussi. So here I just have a 2D grid. Here's the Forces. Or a Rungler. So in all three of these cases, I'm just using the 2D input. This could be a gamepad, this could be a controller, whatever it is you want. I can also use descriptors. So in this case, I'm using MFCCs that I've regressed. So whenever there's a hit, it's going to be sending the values and then triggering a low pass gate. Or to show a little bit more of a complex example. So here in front of me, I have a leap motion control. And so when I'm moving around, it's making all of these values. So it's like close to 50 individual dimensions that correspond with each knuckle. So basically each part of my hand is going to it. I've trained a regressor where all of these dimensions are the input, and then the output is presets that I've chosen from the Quantussi. So that gives me a way to take this really complex input here that would be close to impossible for me to individually map all the points and make basically a playable synth with it. So that's the regressor.